Hey everybody, I'm doing question 4 on page 89, and I have completed the question itself with all the calculations, and what I'm going to do is verbally explain it. So I'd like to just establish what the question is right now, and that is, the question is asking us to find delta D when we have a sled going down a slope of 6 degrees, and what they give us is the initial velocity and the coefficient of kinetic friction. And what we have to do before we find delta D itself is we have to calculate the force of the normal, the acceleration subjected to the sled, and the time. So what I have are these two first equations, and this is basically the horizontal F net, and this is the vertical F net. Now, we don't know what the horizontal F net is because clearly it's moving downward, so it can't be zero. But we do know the fact that it is the force of kinetic friction added with the force of gravity that is parallel to the slope. And we'll expand on this a bit further and say that the negative coefficient of kinetic friction multiplied by the normal force added with the force of gravity, sine of 6, will be equal to our F net. And for the vertical net force, we know that the normal force acting on the sled is going to balance out and become zero when we subtract it. Well, we technically add. We technically add a negative value of the force of gravity cosine of 6, and that is seen here. This is our normal force, and then this is the negative component acting perpendicular to the surface. So what we're going to do is we're going to put the value of Fn that we got, which is Fn is equal to Fg cosine of 6, into our first equation right here. And what we get is F net is equal to the negative coefficient of kinetic friction multiplied by the force of gravity multiplied by cosine of 6, and in turn all of this is added together by the force of gravity multiplied by sine of 6. See, as we expand, we realize we don't have the mass, but it's not necessary because we'll just cancel it out. And what we're left with is acceleration is equal to the negative force of gravity multiplied by the coefficient of kinetic friction, cosine of 6 minus the sine of 6. And the reason that we have negative gravity here is that we just factored it out of this whole big equation. And I'm going to take this equation and just continue onwards and input the values that we know, and that is the value of gravity and the value of the coefficient of kinetic friction. The value of gravity itself is not negative because our acceleration is acting downwards in the direction of gravity, so we keep it as a positive value inside the brackets. Now, our acceleration is negative in this case, but it'll make sense once we continue and we find the time. So to find the time, we take the generic equation to find acceleration, which is delta v over delta t. And we know that the final velocity is equal to 0, and the initial velocity is 12. So what we are left with is negative 12, which we then divide by acceleration to find time. And what we get is 35.5 seconds, which this might vary by a decimal or two. So now we have what is necessary to find our delta D. And what we're going to use is one of our first kinematic equation, which is V1 plus V2 multiplied by 0.5, and all of this is multiplied by time, will give us delta D. So we have 6, which is 12 divided by 2, multiplied by our given time, and what we get is 211 meters, and for the sake of significant digits, we will put it as 2.1 times 10 to the exponent of 2 meters. And then you are going to write your therefore statement, and that is going to be, therefore, the displacement of the sled is going to be 2.1 times 10 to the exponent of 2. Hopefully this made sense.